Welcome to the Explainer. All right, let's just jump right in, because today we are talking about something seriously mind-bending: quantum machine learning. This is it. This is the moment where two of the biggest revolutions in computing, AI and quantum mechanics, are finally starting to merge.
And to even begin to get our heads around this, we have to start with a quote from the brilliant Richard Feynman. He basically said, look, common sense isn't going to help you here. The world we're about to explore, the quantum world, it's absurd. We just have to accept nature for what it is.
So what is this absurd world? Let's pull back the curtain on the secret that nature's been hiding at the teeniest, tiniest scales. What makes it all so, well, weird? Well, think about it like this. You've got classical mechanics, right? That's the physics of our everyday world. You throw a baseball, you know where it's going to land. It's predictable. But then there's quantum mechanics. Down at the level of atoms and electrons, the rules just break. Reality becomes a game of chance, of pure probability.
Now here's the kicker. All that weirdness, that probabilistic nature, that's not a bug, it's a feature. In fact, it's the key to unlocking a completely new kind of computing power. But to do that, we have to totally rethink the most basic building block of a computer.
You know a regular computer bit, right? It's like a light switch. It's either a 0, off, or a 1, on. Super simple. A quantum bit, or qubit, though, it's more like a dimmer switch. It can be a 0, a 1, or it can be both a 0 and a 1 at the exact same time. It's a state we call superposition.
And yeah, this is exactly where the famous Schrödinger's cat paradox comes from. You've got a cat in a box, and until you open that box to look, the cat is considered both alive and dead. It's in a superposition. A qubit is the same way. It's both 0 and 1 right up until the moment you measure it. And if that wasn't strange enough, qubits have another trick up their sleeve called entanglement. You can link two qubits together, and no matter how far apart they are, across a room or across the galaxy, what happens to one instantly, and I mean instantly, affects the other. Even Einstein couldn't wrap his head around it, calling it spooky action at a distance. So, you take superposition, you add entanglement, and what do you get? You get an absolute explosion in computing power. To put this number into perspective, a normal 64-bit computer can handle, well, 64 bits of data. But a 64-qubit computer, it can process a state described by over 18 quintillion numbers simultaneously.
So, what happens when you take that unbelievable, almost unimaginable computing power and you pair it with the other massive tech revolution of our lifetime, artificial intelligence? You get this: quantum machine learning, or QML. It's a brand new field that's all about using that massive quantum advantage to supercharge AI. The goal? To solve problems that are just flat out impossible for even the best supercomputers we have today. We're talking about a whole new level of complexity.
And what's so cool about this is that QML isn't just one magic algorithm. It's a whole new toolbox. Scientists are developing quantum versions of all sorts of classic AI tools, like quantum neural networks. The idea is they could sift through enormous datasets and spot patterns that are completely invisible to us right now. And as you can see, this is happening now. Some are being tested, others are already being put to work.
And believe me, this isn't just a science project anymore. Oh no. This is a full-blown, high-stakes commercial race with billions and potentially trillions of dollars on the line to see who can build this stuff first. And right at the front of that race, you've got companies like Quantinuum. They're making some of the biggest breakthroughs in actually building the physical hardware that this new form of AI is going to run on.
Now check this out. Working with Microsoft, they recently showed off a machine with 12 stable, usable, logical qubits. Okay, 12 might not sound like a lot, but that word logical is everything. This isn't just about packing more qubits onto a chip. It's about making them high quality and reliable enough to do real work. It's a huge, huge milestone. And of course, when the ambition is this big, the money follows. In just a single funding round recently, Quantinuum pulled in around $600 million. And look who's writing the checks. Industrial giants like Honeywell, and, yep, the undisputed king of AI hardware, NVIDIA. That funding round shot the company's valuation up to, get this, a massive $10 billion. That's not just hype. That is a crystal clear signal that the smartest money in the world believes this technology is about to have an enormous impact.
And just look at who's getting on board. This isn't just tech companies talking to other tech companies. You've got giants from finance like JP Morgan Chase,
From pharma like Amgen, huge global investors like SoftBank, they are all making partnerships to get ready for what's coming.
So, all this money, all this hype, it brings us to the most important questions of all. What can this technology actually do? And if it's so great, what's stopping it from changing the world tomorrow?
While the promise is just staggering, we are not talking about slightly better phone apps here. We're talking about designing life-saving drugs in a fraction of the time, creating revolutionary new materials, building hyper-efficient batteries, and financial models that can predict risk in ways we can't even dream of today.
But, and this is a really big but, the problems are just as massive as the promise. Today's quantum computers are incredibly fragile. Even the tiniest bit of noise can wreck a calculation. Training these new AI models is really hard. They sometimes hit these barren plateaus where they just stop learning. Honestly, the basic software to even run these things is still being built as we speak. Which leaves us with this final, kind of profound thought. For the first time ever, we are building a machine that doesn't operate on human logic. It operates on the truly absurd fundamental rules of nature itself. It promises to help us solve our biggest challenges, from disease to climate change. So the real question isn't just can we build it, it's what are we going to do with it when we do, and what entirely new problems might it create along the way.